Hi, today we're going to get to the finale of completing the square. So just a reminder, we can take quadratics in the form x squared plus bx plus c. Generally you're given b and c as the numbers, so here's an example. And we can write it in this form here, x plus p all squared plus q. P and q are some other numbers. So our example, basically we're going to halve the 4, so we get x plus 2 all squared. We're going to minus 2 squared, which is 4. And then we're going to add the 10, that's going to leave us plus 6. And we've seen there's lots of applications to this. We can get the turning point, and we can solve the quadratic if it was equal to 0, or even some other number, for example, but generally equal to 0. Right, so what we're going to look at today is what if we have it when there's a number in front of the x squared. We factorize ones like this. We've used the quadratic formula on ones like this, but what about completing the square? It's just an extra step we have to take. Actually, it's not loads more complicated. It's not actually as difficult as a step up from factorizing quadratics like this to like this. I think it's a bit nicer, but it's just a little trick we need to be able to take, and then we can write them in this form here. So I'm going to go through one, and I'm going to ask you to try some yourselves. We're going to be building it up. Okay, and we're going to solve them as well. Here goes then. So we're going to write this in completed square form. Well, here's what we do. We actually factorize a 2 out. So I'm going to get x squared minus 4x. But actually, because I always get a constant by itself at the end, I don't worry about factorizing this. I just leave the constant outside the bracket. That's okay. I mean, it's not fully factorized, but there's just no need. If you did, you'll see at the end that it didn't really help. So leave it like that. Because now what we can do, and I'm going to need to use multiple brackets, I'm going to use a square bracket, is that I can complete the square on this because we know how to do that. It's going to be x minus 2 all squared minus 4, and I'm going to close the bracket. See, this is why I've used square brackets and then normal brackets, because you can see which one links to which a bit more easily. And then we're going to add 1. Now, I multiply this bracket back out. So I get this, and then I get minus 8 plus 1. And I'm done, basically. I just need to sort out the constants. It's going to be minus 7. I've managed to complete the square on this function. So to solve it, we're going to use completing the square. Well, all I need to do now is set this thing equal to 0. And then add 7 to both sides. This is just like we did last lesson, in fact, if you looked at that. Okay, but this time we don't take the square root quite yet. In theory, we could do, but you shouldn't. It's just best practice not to. You have to square root the 2 as well. Best practice would be to actually divide through by 2 first. 7 over 2. Now I take the square root, and I'm going to get the square root of 7 over 2, and then it's going to be plus or minus. And my final answer is going to be x equals 2 plus or minus the square root of 7 over 2. That's it. Of course, I could write it separately. I've run out of room here, but I could write x equals 2 plus the square root of 7 over 2, or 2 minus the square root of 7 over 2. Not too worried about that today. I'm absolutely happy with this because the main thing I'm trying to get across is this process. All right, how are you feeling about that? I hope it's okay. Assuming you can remember how to complete the square, it should be okay from here on. It's just this initial step that you've got to remember to do. Okay, try this one yourselves. Pause the video and then I'll go through it. So similar process, but this time I'm going to factorize a 3 out. It's going to be x squared minus 4x, and then the 10 is here. Square bracket, I'm going to again complete the square on x squared minus 4x, so that's the same as before. Multiply it back out, minus 12. And there we have it. 3 bracket x minus 2 bracket squared minus 2. I'm going to set that equal to 0 because we're interested in solving it. That's the completed square form. Did I say this before? I can't remember. I could even get the turning point if I wanted to. It doesn't matter that there's a 3 there. The minimum is still going to be minus 2 when x is 2. That's not actually something I'm going to focus on today, but you can still get the minimum point of these functions. I'm more interested in solving. So if I set it equal to 0, I can then, I'll show all the steps. Then I can add 2 to both sides and divide by 3. So, okay, I'm going to skip a step there. It's going to become 2/3. And that means x minus 2 is going to be the square root of 2/3, but plus or minus square root of 2/3. And I'm basically done. X equals 2 plus or minus the square root of 2/3. Well done if you got that. I hope it makes sense. Couple more to try. We are going somewhere with this as well, which you'll see in a minute. Okay, same again. Factorize 5 out, but leave that constant by itself. Square bracket x plus 1 squared minus 1 plus 2. It's going to be minus 5, it's going to be plus 2, it's going to be minus 3. I'm going to go straight there now. Solve it equal, and that's my answer. Solve it equal to 0. I'm going to add 3 to both sides and then divide by 5. Take the square root. Minus 1 plus or minus the square root of 3/5. Same method every time, okay? This one. Oh, I put in a bit of a cheeky one to end with. X squared plus x minus 7. So now this is just slightly more awkward. There's a reason I've implemented this, put in this one, I should say. Okay, it's actually going to be a half. I wanted to bring a fraction into it. To get x is a 1 in front of the x, essentially. Yeah, you don't see it, but it's there. So I need to halve that, just like I've been doing before. This will get me back to x squared plus x, but I need to minus a half squared. It's actually a quarter. And actually I get minus 1 when I multiply it back out, so I'm going to get minus 8 overall. That's it, that's me completing the square. I'm going to set it equal to 0. Whoops, I missed the minus 8. Minus 8 equals 0. So x plus a half squared is going to equal 8/4. It's actually going to equal 2. X plus a half is plus or minus the square root of 2. So x equals minus a half plus or minus the square root of 2. Brilliant. Here goes then. This is the main reason for this lesson, actually. At GCSE level, it's the hardest bit, but it's the most interesting bit and the most general. What if I was asked, if I was given this quadratic, I've got rid of a is 1 again, but now I'm working more generally. X squared plus 2bx plus c in completed square form, and hence solve this. Just do what we've been doing before. Try this out. So it's going to be x plus b all squared. I'm halving the 2b, and then there's a minus b squared, and then write it as plus c. Actually, that's it. One line to complete the square. I can't simplify this. Now I'm going to set this equal to 0. That's going to leave me b squared minus c. So x plus b is going to equal the square root, and I have to put it around the whole thing now, square root of b squared minus c plus or minus. I cannot separate this. When I'm subtracting things inside a surd, you can't do anything with that. And I'll get minus b plus or minus the square root of b squared minus c. That's my answer. Yeah, I can't simplify it anymore. And this is general for this quadratic formula. And here goes. This is the tricky one, but persist with it if you can, because you'll see something happening hopefully. If not, then I'll guide you through it. Can we take a general quadratic? You can't write it any more generally than this. Complete the square on it, and then solve it. Okay, so we're going to use what we've just been talking about. We're going to factorize out an a, just like we factorized out a 2 or a 3 or 4 or 5. But now, when I factorize out an a, we're not used to doing this, but you're going to get b over a as a consequence, plus c. That's the first line. Now I'm going to do the same as I did before. I'm just going to keep maybe linking it to this. Look, this is what I did. And I halved the 2, completed the square, and so on. So now I've got to halve the b over a. That is actually b over 2a. That is the simplest way of writing it. And then I'm going to be squaring it. Let me just make that a little bit neater. And then I'm going to minus b. I'll write it in a bracket first of all. B over 2a all squared. Close bracket plus c. And then I'm going to expand the bracket, just like before. But I need to minus a times whatever this is. Now actually, when you have this thing squared, you can square each term separately. So it's going to become b squared over 4a squared. And when you times a by this thing, you can times by the top, and then essentially you can cancel out the a with the a squared. So let me write this out just one more time. It's going to be minus b squared over 4a plus c. That is completed square form. I can't simplify it anymore. It would actually give me the general turning point for any quadratic. And you know what? I'm going to write it down. Let me just let's close this because that's done. But the turning point of this one, just as an aside, would be for my y value minus b squared over 4a. Do you know what? It's probably best to write it as c minus b squared over 4a. That's my minimum or my maximum, and it's going to be when x is minus b over 2a. That will always be the x value of the minimum. It's pretty interesting. I think we can find a turning point generally. Actually, that's not my main purpose for doing this. It's just an aside. The main purpose is to now set it equal to 0, and I think I'm going to just make a little bit more room. A x plus b over 2a squared minus b squared over 4a plus c equals 0. We now want to solve this using completing the square. Now I know there's lots of letters going on, but just treat it the same as we did before. We got this all onto one side and we're left with the squared thing by itself. That's got to be the aim. So let's do it bit by bit. this is going to equal b squared over 4a minus c. Now I could divide by a, but before I do, a really good idea would be to write this over a common denominator. You might at this point have spotted some things going on, and when I put it over a common denominator, you definitely will. If I put it over a common denominator at 4a, then I need to multiply this by 4a, and at this point I'll tell you, we are actually deriving the quadratic formula. You can see the b squared minus 4ac in there. How can we get the rest of it? You could even write down the quadratic formula, and if you've forgotten, here it is. And this can help you. Like, I do want you to try this yourselves. X equals minus b plus or minus b squared minus 4ac square rooted all over 2a. That's where we're trying to get to. So you can use that along the way. Okay, the next thing to do is to divide through by a. And I'm going to do that in one little go. I'm going to divide that by a, and that becomes a 4a squared there. If you're not happy with that, you can imagine doing something divided by a equals something times 1 over a, because this is a over 1, so you can basically flip it around, and then you can see how it ends up on the bottom, hopefully. Okay, I'm going to take the square root. So x plus b over 2a is going to equal the square root of b squared minus 4ac over 4a squared. Don't forget the plus and minus. It's starting to look a bit like it. It's just how to deal with this. How do we get this 2a? Well, this is how we do it. We use our knowledge of surds, and we can actually split it up into two square roots. B squared minus 4ac over the square root of 4a squared. And that is just equal to 2a. So it's going to become x equals minus b over 2a, if I minus from both sides, plus or minus the square root of b squared minus 4ac all over 2a. And all I need to do is put it, add my fractions essentially, just like when you do a seventh plus 2/7 is 3/7. I can write it all over a common denominator, and so the final step is actually to take us to here. So this lesson, the main purpose was to derive the quadratic formula. To be honest, this is more of an A-level topic to complete the square on things like this, and deriving the quadratic formula is not on the syllabus. However, surely you want to see where that has come from. We've been using it. It's a cornerstone of maths, to be honest. I would say, and we've just got there by completing the square. Now, if I helped you along the way, my challenge to you is go back and see if you can do it completely from scratch. Can you start with ax squared plus bx plus c equals 0 and get to here? That would be a really good achievement. Okay, thanks for watching. I hope this makes sense, and congrats on deriving quadratic formula.